GLEX Global Exploration.
Good morning, everybody. So with this talk, I will bring you to another underworld, the one of caves. And caves are really one of the last less visible frontiers of exploration in this planet. They have been very important for humankind because we have been using the entrances of caves around the world during all the journey that we started from Africa almost 200,000 years ago, to then reach every corner of the continent. Caves have been our house. But still now, in the modern times, caves are something mysterious. There is a lot to explore. We don't know many things about caves, and we cannot see them from satellites. We have no images, no way, no technology that can tell us what lies below our feet. So I'm a speleologist, I'm a geologist, but I'm a speleologist first. I started go caving because I had this giant cavern just not far from the home where I grew in the Alps. And at the beginning it was scary. It was kind of big entrance, darkness, tales from the village, people saying there were people lost there. And the fear to find something that was dangerous. But then when I was about 8, I was so curious, the curiosity to see down there, and I went down with a lamp, and I discovered that it was a kind of playground, which was incredible, just in my backyard. So one characteristic of caves is that you can explore without going too far from your home. And after that, I tried to, of course, visit many caves in the Alps. When I was 15, I went down this giant chasm, Spluga della Preta, 900 meters deep. To get to the bottom, it was kind of 45 hours of descent and climbing up without sleeping and resting. And when I came out, I realized how difficult it was to tell to the people and to show to the people what is underground. Because a cave is not like a mountain that everybody can see. It's not something that you can see on Google Earth. To really understand what is down there, you have to go there and explore and bring your light. And every step, you see something new. It's really extremely complicated to explain what is the underworld. We are biased because we think as creatures living on the surface of the planet that caves are something narrow, maybe not uncomfortable, dirt with water, and some crazy people are going there just for having fun. But in reality, caves can be huge. And now, after 150 years of serious speleological exploration in the last centuries, since the 19th century, we know that caves can be something quite incredible. We have chambers like this one in China that are 20 times bigger than any structure that has been built by humans. We have caves that are hundreds of kilometers long, like Mammoth Cave, but there are many others, even underwater in Yucatan. Really labyrinth, and we still don't know how much is missing. We have been reaching very crazy depths below the surface of the Earth. Consider that in 1956, French speleologists descended for the first time below 1,000 meters from the surface in Gouffre Berger, but now we have more than 120 caves around the world that are overcoming this depth, and we have 2 in Caucasus region that are more than 2,000 meters deep. And here you see these photos from National Geographic photographer Robbie Schoen, which is quite amazing because it's the deepest photo ever made on Earth. This is the bottom of the Ryovkina, the deepest cave in Caucasus with 2,212 meters of depth. So we have an advantage now compared to my trip when I was 15, that we can, with technology, show these places to the public, and we can try to get humanity understand what is down there, really. And one of the main questions is, what is left to explore? And we know that there are about 40,000 kilometers of caves mapped by speleologists. But what is still missing is probably huge. 20% of the surface of the planet is karstic, so can host caves. And what geologists have calculated is that we could have more than 10 millions of kilometers of cave passages on this planet. Caves are also places where we are learning to be surprised by nature. Nature can still overcome our imagination. This is a drawing from Jules Verne's book, Journey to the Center of the Earth. I was imagining this crystal chamber, and in 2000 in Mexico, a mine hit a big cave, Nika, with gigantic crystals up to 12 meters long. And this is just a window open to what is down there. Okay, it was just accidentally found, but we do not know how many of these caves could be at 3-4 kilometers of depth, maybe just below our feet, in water, in hot waters, with the incredible formation that we cannot even imagine. Caves are also time traps. So this is something that we discovered in the last 30 years. If you think about 30 years ago, a few people were talking about cave science. Now cave science is something very cool. A lot of people want to deal with that because while exploring the caves, we discovered that whatever is going through this cave, or let's say is forming inside the caves, can be preserved for much longer times than the surface of the earth. So paleontological remains, many of the prehistorical sites where we can learn about the history of the evolution of the humans, but also mineral formation. Even a stalagmite, imagine that a stalagmite 45 centimeters long can tell you about the climate as much as a drilled core of ice in Greenland of 1,200 meters. Get the same information inside. And also life. Life, of course, evolve and adapt to live in the underground, which is something quite important, because now we estimated about the 30-40% of the biomass is underground, and it forms mainly of bacteria and small animals, but is down there, and we don't know really a lot about it. So I was lucky to be part of an expedition, many expeditions, but this one specifically in 2013 in the Tepuis of Venezuela, where caves were really showing to us the concept of geological time. This place in the Guyana Shield are mountains made of quartz, very ancient, and nobody was thinking that caves could form there because it's very hard rock. And since we were searching for many years, and in 2013 we discovered this giant cave, Himawari Yeuta, the house of the gods, named by the indigenous people. And this is an incredible place, completely different from any cave that we can go and visit around the planet. It's estimated to be from about 50 to 70 millions of years old. It is completely covered in quartz, so the formation is completely different from any touristic caves that you can see in karst areas. And while walking through this cave, the scientists were really surprised because everything that we were looking was completely new. There were new minerals for science, these crazy formations that at the beginning we didn't know what they were. They were silica, opal, but then looking and studying them, we discovered that basically they are formed by bacteria. So they are living stromatolites in the darkness of a cave using chemical elements to get energy, forming bacteria community, very complex, with very strange shapes. And there is still a lot to discover. And that was quite an important scientific achievement because we showed that underground bacteria community can thrive without many interaction with the surface. They can grow and use mineral structures for functional purposes. And so we can have an entire ecosystem down there. The cave is really fabulous. You can see red waters due to tannic water coming from the outside, but you can see also violet lakes, which are being colored by the bacteria living there since millions of years, producing antibiotic substances. And so it was for me like going into another planet. And still there is a lot to explore and to discover. The discovery of the opals was also interesting because This opaline formation with bacteria are very interesting because also on Mars, the Spirit rover found opaline formation on the ground, and there are debates between astrobiologists about the potential preservation of biosignatures in opal. And so finding something like this in a cave on Earth, and we know that on the surface of Mars, life now cannot exist, but underground it could be, because it's protected from cosmic radiation, is something that inspires us to go and explore also beyond the surface of other planets. These caves, quartzite caves, we were thinking it was only in Venezuela, in the Ollantaytambo, but in the last years we have been doing expeditions. These are photos from my last expedition in February to the Chiribiquete Massif in Colombia. Huge quartzite mountains, and we discovered many caves with the indigenous community, gigantic cave systems made of quartz with stromatolites also there. And it is telling us that there is a lot in the Amazon still to explore also underground. But aside of telling something about the past, caves can tell something also about the present and the future. And we are completely changing environment, and we are looking now to ice caves. So with my team, La Venta, we have been doing expedition to ice caves since more than 20 years. And we have been witnessing the changes of glaciers around the world, looking to their inside. This is in Greenland, giant rivers, meltwater rivers in summer, just sink in these caves. They can be very huge and change and disappear then in winter. They are beautiful, they're really incredible environments, very ephemeral, very dangerous, very scary, because they continuously evolve. And what we are doing now is trying to understand what is going on inside the glaciers. They are also blue. You see, it's the only type of cave which has light inside, because the blue wavelength is reaching the underground. And so sometimes they are also green in Greenland because of the northern lights. And in the Alps especially, we are trying to explore and understand how much meltwater is bringing heat down inside the glacier, and how much our models of estimating the retreat of glaciers from the surface, from satellites, could be wrong, because something is happening inside. I always say it's like a Swiss cheese that is full of holes, and at a certain point the glacier could collapse. This is the Matterhorn, just from inside. And now we have technologies like this drone that can go, and this is a collision-tolerant drone, can go and explore the caves, getting 3D models, temperatures, and getting for us information without us going there and risking our life, because as I said, it's very, very dangerous places. So these are the most ephemeral caves on Earth, and a place like this already doesn't exist anymore. This was just 1 year ago, and the glacier here has been retreating, so it is a cave that doesn't exist anymore. Other places that are very important for caves exploration are volcanoes. Like here in Azores, volcanic caves have been not very, let's say, considered by scientists in the past, by speleologists, because they are not so deep, sometimes they are not so long, but they are extremely interesting. And especially in shield volcanoes, we can have this kind of conduits that bring lava below the flows, which are lava tubes. This is in Lanzarote, the gigantic tube of La Corona. And they are very interesting and important because we know for sure that this type of caves could exist on other planets. Because volcanism has been active on the Moon, on Mars, on Mercury, on Venus. And so there should be something like that, even probably much bigger on other planets. Actually, we know that there are entrances on the Moon. You see this is here on the Moon. We have more than 200 cave entrances on the Moon, especially in the volcanic regions. We have more than 1,200 entrances detected on Mars. This is one giant pit on one of the volcano of the Tarsis region, 300 meters high, this wall, but we don't see the bottom. We don't know how deep it is. So there should be something down there, as on Earth. There should be something down there, and could be very interesting. And we cannot see. It's something that we cannot see from the satellite images. We have very good, even 1 meter resolution satellite images from Mars, even less. but still the underground is the really dark side of the planet. So we are trying here on Earth to push forward this kind of exploration. These are some photos from just 10 days ago. We had a big expedition in Iceland funded by National Geographic trying to understand what is going on inside lava tubes that are still hot, formed during the eruption of Fagradalsfjall, the big eruption probably you remember 2 years ago. They are still between 300 degrees and 50 degrees. There are metastable minerals. There are very weird things that have never been studied in terms of mineralogy. And we have been inside tubes with this special equipment for up to 300 degrees Celsius, taking samples. And we were searching also what are the ways life is coming back. This is a completely sterile environment, but at a certain point, bacteria are able to get there, and they colonize this environment. And so it could be something that could have been happening also on Mars. If there was life on the surface, then it could have found refuge underground. Caves are, like lava tubes, are places where we can find also resources like water. This is something that is also an hypothesis for Mars and eventually even the high latitude regions of the moon. So they are considered places where we could also find resources for human exploration, human space exploration in the future. And also they are places that are protected from radiation. They are protected from the temperature excursion of the surface, which can be extreme on other planets like the moon and Mars. So they could be places where we could find a new home if we want to explore further other planets. So we started from caves as home when we were in the beginning of our history, but we could use them in the future. So I want to finish with this photo. You see here 2 astronauts, Alexander Guest from ESA and Stephanie Wilson from NASA. Now space agencies are very interested in the topic of caves because of this possibility to use them or to explore them in the future. ESA is training astronauts in caves for future exploration. We have been training more than 35 astronauts from 5 different space agencies. And there is this merging of interest between the exploration of space and the exploration of the underground. And recently we had in Lanzarote a big conference with NASA and ESA, more than 100 researchers from around the world, trying to push the idea that we have to go on the moon. Yes, we have to go back. We have to go to Mars, but we have also to look beyond the surface of this planet as we are doing here on Earth, because there could be some incredible discoveries. Thank you very much.